Hello guys, welcome to another episode, and today we are going to discuss about the basics of a transistor. But what is a transistor? A transistor is a semiconductor device that switches or amplifies electrical signals and power. It is one of the basic building blocks of a modern electronics. It is composed of a semiconductor material, usually with at least three terminals for connection to an electrical circuit. A voltage or current applied to one pair of the transistor terminals controls the current through another pair of terminals. A transistor can amplify a signal because the controlled output power can be higher than the controlling input power. Some transistors are packaged individually, but many more in a miniature form are found embedded in the integrated circuits. But let's discuss more specifically about the bipolar junction transistor or BJTs, which is a type of a transistor that uses both electrons and electron holes as charger carriers. A bipolar transistor allows a small current injected to one of its terminals to control a much larger current flowing between the terminals, making the device capable of amplification or switching. But let's see now some basic types of transistors. So the first type will be the bipolar transistor or BJTs as explained, which has two categories. One is the NPN and the other is the PNP. And the second category is the MOSFET or metal oxide semiconductor field effect transistor, which has two channels, channel N and channel P. And last but not least is the IGBTs, which is the insulated gate bipolar transistors. And practically it's a combination of a MOSFET and a BJT transistor. In this video, we'll cover the bipolar junction transistor with a terminal label base and collector and emitter, which is practically the representation of the NPN. And as you can see, the current flows to the base and the current from the collector flows towards to the emitter and from the emitter to the ground. Another type is the PNP, and as you can see here, the base current is flows away from the base, and we have the collector current which flows to the ground, and the emitter which practically from the top to the collector. But let's see now a very simple representation of the current flow and also try to resolve a simple calculation and find out the current to the collector and also to the emitter. So this is how the current flows to this specific transistor. And let's assume that the beta or HFE, which is specified in the dataset, it's equal to 200. At the moment, we don't have a specific transistor, but if you find a specific transistor, you can find this value in the dataset. And we know that on this specific transistor, the current on the base is 50 microamp. In order to find the current to the collector, you need to do the simple multiplication between the beta or HFE by the current to the base, which is 200 multiplied by 50 microamp, and it's equivalent to 10 milliamp or 10,000 microamp. And in order to find the current across to the emitter, it's practically we add the current of the collector and the current of the base, and we can easily find the current across the emitter. That was it for today. I hope you enjoyed the video, and I will see you in the next one.